Well, hello everyone. For this video, we're going to see the distribution of the mean. Now, the mean is one of the most important forms to analyze the data that we have. Now, we have seen that from a population we can extract a sample and from that draw conclusions to the population. So we can do this. We can draw. Well, we can calculate the mean from this population. So, for example, we can also we can also calculate the expected value. So, for example, if we want to get this part, the expected value, if we have like a very optimistic form, it will be equal to the mean value of the population. This is because it should be equal to the mean, but because we have like different sizes of samples that we can get, it would always be equal to the mean of the population. But if we keep like adding data to our sample, if we keep making bigger sample, it will give us this value at the end. So what can we do with it? With this, if the sample doesn't give us the real mean, why do we calculate it? Because it can give us a variance and something that is like relevant to that calculation. Because if we now calculate like the variance of the sample that we are using for our analysis, it will be equal to this part. That will be like the variance of the sample. But we can know from this equation that given that we have the variance of the population, the variance of the sample will be equal to the variance of the population over n being the number of objects that we are using. Now, what this gives you is that for bigger n, we can get something more related to our population, because this will be much more closer to the value that we will have to obtain. So if we substitute and get the standard deviation, it will be equal to this. So with this we have like the form in which the variance also of the population will behave, because we can solve for the variance of the population, which give us this value, which will be useful for our formulation when we are choosing our sample and the size of our sample, to see if it's like relevant given that n sample. Now, other thing that is important is known as the central limit theorem. Central limit theorem. What is it? Well, given that you have, for example, an n size sample, if you have a big enough number of events in your sample, it can be approximated as a normal distribution, which, as we know, is like the one that has a bell shape. That is a Gaussian distribution, or what's called a normal distribution. So this, if you have like any kind of population, if you extract a really some considerable number of data, we can do simplification to this kind of distribution that can make our life more simple in this kind of distribution. For example, if we have like the binomial distribution, if we sample that part with a big enough number of events, we can substitute it for a normal simplification. Now, what is a big sample? How many is enough to consider this substitution? Well, there is a thumb rule that says that basically n over approximately 30 events or objects inside this can be used with a normal distribution assumption. Now, well, this is everything for this video, and thank you.